Hello and welcome to this video about Python for data handling. In this video lecture, you will learn about the dictionary, which is a Python native data storage abstraction, or you could say Python data storage abstraction. The Python dictionary provides speed, data key pairings, and ensured uniqueness of dictionary keys. When using Python and/or Pandas for data handling, dictionaries are often used to create mappings for name changes, mappings for transformations, or mappings to create input for Pandas data frames. Dictionaries are also frequently used as an effective tool to create mappings between data items or values and translations such as colors in plots and graphics, or to create labels for classes. Dictionaries are a very useful tool to know for data handling purposes. Now we'll talk about the Python dictionary data type, and the dictionary is a collection that requires data to be stored in key plus value pairs. And the dictionary is a quite modern addition to current programming languages and is mainly used for speed and the ensured uniqueness of keys within collections or data sources for data science analysis or machine learning tasks. The enforced uniqueness of keys is very useful for data security in data handling tasks and may, for example, by design, prevent multiple values where uniqueness is required or wanted. The properties of the Python dictionary are that dictionary items, which are key plus value pairs, are ordered by the insertion order, changeable, and that dictionaries don't allow duplicates of dictionary keys. A dictionary key is restricted to strings, numbers, or tuples with arbitrary values, as long as the values are immutable with some restrictions to the object types. Dictionaries are indexed by their keys and may have any current Python object as data values, including other collections or even Python dictionaries. And on the screen, you can see an example piece of code that shows some Python dictionary code and is a fictitious mail catalog where a person's fictitious name is used as a string key and a fictitious mail address is used as string data or string values. Now we'll type some Python dictionary code. So let's start up your code editors. All right, having started our code editors, we will type some Python dictionary code. And we will start by typing the string object mail catalog code example from the PowerPoint. So we will begin to type Python dictionary. And we will create a Python dictionary with 3 key value pairs consisting of a string key and a value string. We type mailcat equals Joe for the first key and joe.joe@gmail.com. We add the second key as an and, and we add the third key, Lisa, and we will print our male cat, and we will print the type of our male cat. So let's run this code. And here we can see that we have the class dictionary, and we can see that we have our dictionary with 3 key value entries. And the first thing we'll do is that we will add a new instance. Muhammad to the dictionary. We type male cat, Muhammad equals Muhammad@gmail.com. And we can print the male cat. So let's run this code. And here we can see that we have added a new instance of key value pairs to the dictionary. So here we have the key Muhammad, and we have the string value of this Gmail address. So here we can see that we can add new instances using assignment. And we can say that a dictionary is created with a name, the equality sign, and 2 curly brackets. We have the name of the dictionary equals something within these brackets. What we'll do now is that we will add an integer key string instance to the male cat to show its versatility. We type male cat 5 equals, this is a string with an integer key. And we can print the male cat. So let's run this code. And here we can see that we have added a key, integer 5, and a string. This is a string with an integer key. Now we will show some ways to address and print the dictionary keys and items. We print mailcat.keys. We can print mailcat.values. And we can print mailcat.items. And this will print the dictionary's key value pairs as a list of tuples. So let's run this code. And here we can see that we have the dictionary keys printed. So here we have the keys as a list. Here we have the values. And here we have keys and values when we refer to the dictionary's items. And we have some more methods, or you could say functions. We can print, for example, mailcat.lisa, which refers to the key Lisa. And this will print the value of the Lisa key value pair. And we can print mailcat 5 and this will print the value for the key integer 5. And we can also print mailcat.get. Lisa. And this will return the value for the key in the dictionary. And if not found, it will return a default value. And here we can say that it is important that you note that key names must be correctly specified with upper and lower case characters wherever appropriate. And this is quite different from mail addresses, because mail addresses tend to always be lower characters. So you can type them with upper characters, but when you use them, they will always be interpreted with lower characters. So let's run this code. And here we can see that the value for Lisa is lisa@gmx.com. The value for 5 is this is a list with an integer key. And the return for get Lisa is lisa@gmx.com. All right, now we'll talk some about changing the value for a key in the dictionary. And this is done with assignment. So we type to change a value in the dictionary. Assignment can be used. For example, we can type mailcat Joe equals Joe to Joe 2 at gmail.com. And we can print our mailcat. So let's run this code. And here you can see that Joe.joe was changed to Joe2.joe2. And for example, if we want to delete a key value pair or an item, type delete mailcat 5, and we can print our mailcat. So let's run this code. And here you can see that the key 5 with its value has been removed from our dictionary. All right, now we're going to type some advanced dictionary functions. And we must say that if these functions feel complex or advanced or even hard to grasp right now, we recommend that you return to this video after completing this entire video and Python section. So when you have completed this section, you return to this video lecture, and if these functions still feel complex, you can try the Pandas section or course and return again. And all will be clear with some practice and exercise. And as you know, practice and exercise makes the master. All right, we will start with the length function, which returns an integer describing the number of items or elements in a dictionary. We can type print the length of the mailcat. So let's run this code. And here we can see that we had the integer number 4 returned, and we have 1, 2, 3, and 4 key value instances in our dictionary. And we can use the string function to cast, or you could say create a string of the entire dictionary. And we can say that this may be useful in some text mining applications. So let's type print string mailcat, and we can print the type of the string of the mailcat. And we can say that this will return a string within curly brackets. So let's run this code. And here we can see that we have the class string for this object and that we have a string within curly brackets. And now we'll test some loops on our dictionary. And we will primarily use for loops. We can type that this for loop iterates through all the keys in a dictionary, and the function will print each key on a new line. We type for M in mailcat, print M. And here we can say that the default for the dictionary when we type print M is the key. So let's run this code. And here we can see that we have our 4 keys printed, each on a new line. And we can do this explicitly. We type for k in mailcat.keys, print k. So let's run this code. So here we can see that this instruction, in principle, we could say executed the same work, but it actually didn't do exactly the same work, but it created exactly the same result for this dictionary. And we can say that we can print the values in the same way. We can print for we in mailcat.values. Print we for value. So let's run this code. And here we can see that we printed the values of our dictionary. And now we will type a loop that iterates through all key value pairs in our dictionary and prints each key value on a new line. We type for key and value in mailcat.items, print key and value. So let's run this code. And here we can see that it printed the key and the value, the key and the value. So now we'll talk some about nested dictionaries. And these are very complex constructions that exists nowadays because programmers tend to enjoy to create advanced databases and advanced object-oriented constructions. And what you sometimes end up with is dictionaries of the nested type, where, for example, one dictionary may hold a number of, or even a hierarchy of nested dictionaries. And this can be very efficient when you code it to store data, because you can create a lot of nested dictionaries which can handle, for example, sparse data matrices. But when you extract this data from the database, if the programmer hasn't taken account and created functions for all possible scenarios, which they never do, then you could have a data handling issue with these nested dictionaries. And these issues can take many different dimensions. One is that you can get a matrix of data which is a lot more sparse than it should be. And the other is that you get the nested data in a nested fashion, and that you will have to execute very advanced data handling in order to actually use the data. And for most university-educated programmers and data analysts, there is a huge gap between the requirements to properly analyze these databases and their current capabilities to actually do so. So here we will teach you very valuable information. So all right, let's begin. Nested dictionaries. And we will create a dictionary inside our current dictionary. So we type mailcat, special mail, equals a dictionary, and the first key is Rolf. Rolf and we create a second key, and we close the dictionary, and we can print our mailcat, and we will cast it as a string. And we can say that this is a nested dictionary with a complex multi-type structure. So let's run this code. And here we can see that our nested dictionary has been added to our dictionary. So here we can say that we have a dictionary with a double structure. So you have an ordinary dictionary and you have a nested dictionary. And this creates a complex object-oriented data structure. And we can say that currently there is no inbuilt, easy accessible Python function to handle these multi-type structures. And this means that you will have to write all the code yourself to handle them. And the first thing we will do is that we will type a for loop using the direct known address of a part of the multi-type structure we type for key and value in mailcat specmail. We can type name and address equals key and value. And we can print the name and the address. So right, this code will iterate only over a small part of our dictionary, and we will only iterate over the specmail part of the dictionary. And this is what we specify here in the first part of the for loop. And the second part is that we will only iterate over the items. And this makes sure that we will only iterate over key and values. And in the second part of the for loop, we will unpack the key and the value to name and address, and we'll print the name and the address. So let's run this code. And here you can see that you have the key and the value of this nested dictionary. So what you can do with this for loop is that you can extract this information and you can put it into a new dictionary and you can add these dictionaries together. For example, manually or automatically. And this is a bit interesting, so we can continue to type and we can use keys and direct known addresses on exactly defined part of the multi-type structure. And we can say that this has many different solutions. So there probably are 10 or 20 different ways to type this solution. So we can print the list, mailcat, specmail, keys, and here we can put a 0 and we close the print instruction. And we can print mailcat, specmail, rows. And what the first line does is that it takes the mailcat limits it to the nested dictionary and its keys. And it takes this part of the dictionary or the output or return of the keys function, casts it as a list, and selects the first element of that list, and it prints it. And this will be Rolf. And this other instruction does the same thing, but it points directly at Rolf. And this Rolf will return the value, which is Rolf's mail address. So let's run this code. And here we can see that we have the key and we have the value. And we can extend this to automation. So we can type that here we have a not so Pythonic automation variant, which makes it possible to list and address key value pairs using list position notation. And when we say that the code we will type now is not so Pythonic, means that it is complex and it is overbearing and it uses several casts or conversions to achieve a very useful result. We can type print list mailcat. We point at the spec mail. And we will only use the keys. And the second thing we will do is that we will print the mailcat spec mail. This. We can take this code and we can simply cut and paste it. And we can change zeros to ones. Because as you remember, in this nested dictionary, we had 2 entries and not 1. So let's run this code. And here you can see that we have the key and the value and the key and the value. And this is very useful because now we can address and point at each element and we can create almost arbitrary solutions to collect all information in these nested dictionaries. And the only thing which is bad with this code is that it is non-Pythonic. And this means that it is complex and that it uses a large number of steps to achieve its results, and therefore becomes hard to type, hard to read, and a bit tough to understand. Yet this code is very useful. And now we'll show a Pythonic way to automate the flattening of the Mailcat dictionary to a standard dictionary. And we will delete the nested dictionary. So now we'll show you how to handle exactly this type of nested dictionary and turn it into a you could say unitype or standard dictionary, which you can analyze and use with standard data analysis tools and all such things. So let's type use a Pythonic automation variant to flatten the Mailcat dictionary to a standard dictionary and delete the nested dictionary. So we type for K and B for value in Mailcat spec mail items Mailcat K equals value. And we will delete Mailcat spec mail. And we'll print the resulting Mailcat. So let's run this code. And here we can see that we have a ordinary Python dictionary where the keys and the values of the nested dictionary has been assigned to the standard dictionary. And as a final part of this, you could say, transformation, the nested dictionary was deleted. So right, now we will talk some about how to clear or delete a dictionary. And the first thing we will do is that we will use the clear instruction to delete all elements or items in a dictionary. We can print the Mailcat and we will see what remains. So let's run this code. And here we can see that all we have is an empty dictionary, which is represented here by two, you could say, brackets. And now we will delete Mailcat. And we can try to print Mailcat after deleting it. And this will return an error because there is no Mailcat anymore. So let's run this code. And here we can see that the delete instruction removed the male cat from memory, and therefore the name male cat is no longer defined. So, right. In this video lecture, you learned how to use Python dictionaries, and you learned a lot of useful and advanced knowledge about dictionaries. And in the next video lecture, we'll teach you even more. And we look forward to see you in the next video. Hello and welcome to this video about Python for data handling. In this video lecture, you will learn about the Python list, which is a Python native data storage abstraction. The list provides Python users with a data storage solution which is versatile, extendable, updatable, changeable, general, and a one for almost all situations solution for most types of data storage. Some Python users even consider the lists or modified lists to be the solution for every or any and all data storage situations. The list is a very common data storage tool, both as a standalone object or as an object inside other objects. The Python list is a very useful tool to know for data handling purposes. Now we're going to talk some in detail about the Python list data type. And for data science, data analysis, and machine learning purposes, the Python list data type is the most useful, versatile, and general data storage type available. The list data type is a container for items or objects that are ordered, changeable, and allows duplicate items or values. In practice, this means that with a Python list, we can update, delete, remove, or add objects to the list, or even add copies of existing objects in a list to the same or another list after the list has been created. This is a very useful property of the list, and the list can also accept any type of Python objects, so a list can contain integers, strings, arbitrary user-created objects, tuples, sets, other lists, or whatever object you want to have in the list at the same time. The object types don't matter to the list object. And this means that the Python list is so general that the stored objects don't need to be of the same type. And this property of the Python list has consequences as compared to lists in some other languages. And this consequently means that when you use lists in practice, in applications, you must control whatever object your program put into the list, and both control the objects themselves and the knowledge of the object types. Or if you don't have that knowledge or that level of control, you must check what type of object you get from the list when you ask for the object, or an object at a position in the list. Because when you ask a Python list for its contents, you will receive the contents. And sometimes it may be an integer, and sometimes it may be a string, and sometimes it may be a float, or an arbitrary user-created object. And we can say that many users of Python lists for applications with uncontrolled data input or content recommend the type and value checking both when the object is added to the list and when the object is read or extracted from the list. Another way to obtain similar control levels is to recreate all input objects to a predefined coded object type before adding the new object to the list. There are, for example, advanced instances where the object type is unknown, not defined by Python, or not defined at all, or in some extreme cases defines itself as a Python object of the native type without being so. So it may quack as a duck, but not being a duck. And this type checking may be particularly true for advanced and uncontrolled input or measurement situations, but is uncommon for controlled input or data situations. So when you have your data set in a comma-separated file and everything is proper, and you have these textbooks data set, this may never be a problem. But when you use measurement systems in nature or on humans or whatever, you may get these input or output troubles. And the worst data usually comes from the internet, because when you have some random users sending you data on the internet, either through a web interface or something, you don't really know what sort of data you will actually get. And this can be valuable knowledge for real-time data analysis within internet applications, for example. So right, this description shows the most important properties of the list. The list's flexibility and the need to control the list and its objects either at input time or at output time, or perhaps at both the input time and the output time. So the technical properties of the list are that list items are indexed with integer numbers, and that the first item in a list always has the index number 0, the second 1, the third 2, and so on. Lists has the advantage that we can address a position in the list by referring to an integer number. And Python creates lists through items separated by commas within brackets. And now we're going to take a look at some example code. So start up your code editors, because we're going to type some Python list code. All right, having started our code editors, we will type some Python list code. And we will start to type Python list. And we will create a first list. We type list1 equals integer 7, 4, 3, 9, and the string bananas. We can print the type of list1, and we can print list1. So let's run this code. And here we can see that we have a list. And we can see that this list consists of the integers 7, 4, 3, 9, and the string bananas. We can show how to address list objects using the object's position inside the list. We can type print string list1 3 plus string list1 plus some white space plus string list1 4. And we can type that string list index instructs Python to print the content at position index as a string. And we can say that this is one way to control the output from a list. And it's a flawed way to control the output from a list, but it is effective and it will work for most native Python objects. So let's run this code. And here we can see that we have the output 93 bananas. Now we will operate on list objects using the list notation. We will print type of list 1. And we will print the type of the string of list 1 at position 3. So let's run this code. And here we can see that the object at position 3 is an integer. And here we can see that we have cast this integer as a string. And we can continue and we can say that a list object content may be changed by assignment. We can type list2 equals 2. And we can print list1. And we can say that this will print 7, 4, 2, 9 bananas. So let's run this code. And we can say that new objects can be added to a list with the append method. We can type that we want to append apples. And we can print list1. So let's run this code. And here we can see that we have added apples to the last part of this list. And we can say that we can remove objects from a list using the delete statement or the remove method. We can type delete list1 element 4 and we can print list1 and this will remove the bananas. So let's run this code. And here you can see that list element 4 was removed from the list. And we can also use the remove instruction. So we can type list1 remove apples. And we can print list1. And this will remove the apples. So let's run this code. And here we can see that the apples has been removed. And we can say that Python lists can be added together using inter alia, the plus operator, or the extend or append methods. So now we will create a list 2 and a list 3. We type list 2 equals 1, 4, 5, 6, and 8. And we can create list 3 as list 1 plus list 2. And we can print list 3. So let's run this code. And here we can see that list 1 and list 2 has been added together. And we can use the append method, so we can type list 1 append list 3. And we can print list 1. So let's run this code. And here we can see that list 1 has had list 3 appended at the 4th position as a nested list. And we can type list 3 extend list 2. And we can print list 3. So let's run this code. Here we can see that we have list 3 extended by list 2. And now we will show some properties of the list. For example, how you count the number of objects inside the list, or you could say the number of active object positions. So we will print the length of list 3. And we will print the length of list 1. So let's run this code. And here we can see that list 3 has indeed 14 positions. 4, 6, 8, 10, 12, and 14. And we can see that list 1 only has 5 positions. So here we have the first 4, and this entire list counts as 1 position. So how many elements you get from the length instruction depends on whether you have list brackets for this list at a position, or if you, for example, extends with the content instead of the entire list. So using the append or extend instruction results in different results. And this is something to keep in mind and something to think about when considering lists, and in particular lists of lists. But let's save the list of lists or multidimensional lists for last. So now we will learn to sort list 3. So we will print list 3, and we will sort this list. And we will print list 3 after it has been sorted. So let's run this code. And here we can see list 3 unsorted, and we can see list 3 sorted. And this sort instruction will sort these integers based on the value of the integers in the list. And you can sort them both ascending and descending. And sorting lists are often important within data handling. So right, now we'll address ranges of the list. We can print list 1 to 4. And this will give us in the case of list 3, 1, 2, and 4. Like this. And we can print list 3. And this will give us 1, 1, 2. everything to the left of element 3, which is 4 in this case. And we can print list 3. And this will give us 8 and 9. What we say here is that everything to the right of element 12, and you know that it is 14 elements here. So this is 14, 13, and this is number 12. So all right, let's run this code. And here we can see that we have a list consisting of 1, 2, and 4, 1, 1, and 2, and 8 and 9. And as you can see, this is very useful because here we can point at the number of positions in a list. We can print them, or we can make operations on them. And we will look a bit more at this when we look at multidimensional or list of lists in the final advanced section of this video. Now we will take a look at how to loop a list using for loops. And this is very simple, so we just type for x in list 3, print x. And let's run this code. And here you can see 1, 1, 2, 4, 8, 9. So here we have looped the list and we have printed the list. And now we'll take a look at moving objects from one list to another list. And this is often very important both in data handling and in, for example, algorithms. So you want to move, for example, one object after operation to another list, and so on. We can begin by printing list 1, and we can print list 3. And we can take list 3 and we can append list 1, pop 1. And we will print list 1 and we will print list 3. So let's run this code. And here we can see that from list 1, we have the object at position 1, which is a 4. And that has been moved to the last position of list 3. So this 4 has been moved here. And here we can see that the 4 has disappeared. And we can see that the 4 has been added to this list. And we can move objects from one list to a specified position in another list, we can type print list1, and we can print list3, and from list3 we can insert at position 2 list1, the first item, and we can print list1 after operation, and we can print list3 after the operation. So let's run this code. And here we can see that object 7 has been injected into position 2 on list 3. And we can also see that integer 7 has disappeared from list 1. So all right, now we're going to look at advanced list functions and such things. So if you feel that this part of the video lecture becomes a bit advanced, just continue to the next video and return to this video later. For example, when you have made one pass through this section on Python, you can return here, and for every repetition of this video, you will grow better and more competent. And this should be quite simple, even if you're a rookie after 1 or 2 passes. So, right, now we will take a look at type checking using the type and is instance methods, or you could say functions. And we can say that object type checking may be straightforward when all data is molded into a Python compatible form or a Python form. And we can say that this is not always true. For example, when sent unknown data over the internet, or if you're using analog or digital measurement systems. And we can say that type checking can very quickly become very advanced. So what we will do now is that we will show some basic functions for type checking, assuming a list of integers or the intention to have a, you could say, a list of integers. We can type string test1 equals 1 and string test2 equals 1. So here we have 2 named strings. One is a string and one is an integer. And we will append them at list3. And we will print list3. So let's run this code. And here we can see that we have a list of integers, but that we have a string concealed as an integer inside this list. And in this version of this video, we will not add a bug to this type of type checking, but we want to make it known or make you understand that type checking is very advanced and that it can fail even when it looks foolproof and you have covered all possible types of objects. And this is in particular true for internet data, but also happens with measurement data. So, all right, let's type for x in list 3 if type x is not int, print not integer. Else print integer. And we can type for x in list 3 if instance of x is an int, print integer. Else print not integer. And here we will add some white space. So let's run this code. And here we can see that in both these cases, both these methods managed to identify this string as a not integer. And this is a textbook way of showing type checking. And when you add custom objects or, for example, custom objects that can overlap with Python's native classes, such as, for example, ints and strings, then this quickly becomes very advanced. So, right, now we'll take a look at multi-level lists. Also called list of lists or multidimensional lists. So what we'll do now is that we will create a list 4, which is equal to 1, 3, and 5. We will make a list 5, which is equal to 2, 4, and 6. And we'll make a list 6, which is equal to 3, 5, and 7. And we will make a list 7, which is equal to list 4, list 5, and list 6. And we will play around a little with these lists. So we will print list 7. And let's run this code. And here we can see that the list 7 at its first position has this list. At the second position, it has list 5, and so on. So what we'll do now is that we will show how to address multi-level lists. So we will print list 7, first element, and we will use the brackets to print the second element of this list. So let's run this code. And here we can see that first we identified this first list, and the second number inside the bracket identified this object inside the nested list. Now we'll play some more. So we will type list 4, extend list 5. And we'll print list 7. And this result may shock you a little bit. So let's run this code. And here you can see that list 7 and list 4 are nested objects and not separate objects. And persons who have experienced with older static programming languages might find this a bit surprising, because they intuitively want to believe that this instruction will create an entirely new copy, whereas in Python it does not. So here we can see that list 4 has indeed been extended, and as list 4 is a part of list 7, the object inside list 7 has been extended. And we can take this further. So we can extend the second level, nested list, with a third level list. So we can type list 5, extend list 1, and we can print list 7. Here we have list 5, and it will be extended by list 1. And list 1 we have here. So let's run this code. And here we can see that list 1 is now a part of, you could say, list 5. And it also brought its string with it. So what we will do now is that we will show you how to access third level objects. We type print list 7 1 5 and 2. And this will point at this object first, and 5 will point at this part of the object, the third level, and 2 will point at this number. So let's run this code. And here you can see that it printed the integer 7. And now we'll show you how to access third level objects with a for loop. We type for x in list 7 print x. And as you can see, we use the same part of this nested list. So here we point at this object and we point at position 5, which is this nested list. And now we'll print it using a for loop and a print instruction. So let's run this code. 1172 and so on. And when we print this, they all appear as strings, regardless if they are integers or strings. And this list notation, where we point at the position in the lists and the number of lists which you can nest inside other lists, are only limited by your ability to type finite numbers. However, it must be said that these multidimensional lists become very unwieldy quickly. So it's considered Pythonic to not use more than at maximum 3 nested lists, and preferably use as few nested lists as possible, because it can quickly become very hard to read and understand. And most brilliant people can only visualize in their brain volumes. They can see 3 dimensions, but they can't see 4, 5, 6, 8, or 9, or even more, which could be worse. But most brilliant people can see 3 dimensions. And most educated persons can see 2 dimensions. But almost everyone can see 1 dimension. And this is a great reason to limit the number of dimensions when you have the option and creates this code. Because one day someone else might be using your code. And then it can be advantageous if that person can read and understand the code. So this was some words of wisdom about what is Pythonic and what is not Pythonic in the perspective of Python lists. So right, this has been an exciting video lecture about Python lists And now you know how to use and handle Python lists for data handling and also applications. You have had a great, possible one of the best introductions to the very useful Python lists available. And in the future videos, we'll teach you even more. And we look forward to see you in the next video.